Hi, Algebra 2 friends. Here we are in Chapter 11. We're in 11.2, Arithmetic Series. So here's our vocabulary for this section. So what is a series? A series is the sum of several numbers of a sequence, basically. So if 2, 4, 6, 8, 10 represented a certain, arithmetic sequence, then 2 plus 4 plus 6 plus 8 plus 10 would be the series. So a series really is the sum of the numbers in a sequence, and we know the numbers in a sequence are in a certain order. We're talking about a specific sequence and a specific type of series when we're dealing with arithmetic sequences and arithmetic series. And so this section will be about an arithmetic series. So you can see that an arithmetic series is a series of numbers that are being, or a sequence of numbers that are being added up that happen to be arithmetic. Sigma notation. So to refer to adding up numbers, we use the sigma notation like this. And you can see I'm not profesh at writing it. And so how we would use this is to indicate that I'd like you to add up certain numbers in a particular formula, let's say. So if I wanted you to add up 2 t's, but I wanted those t's to be from, let's say, 1 to 7, then what this expression would represent is 2 times 1 plus 2 times 2. This index number is telling me the starting point, and this one at the top tells me where to end, plus 2 times 3. You guys get the idea? And so you can see this is what the whole thing written out would look like. And then we can see that this expression, this summation expression, really just refers to an arithmetic series like the one we started off with. And in this case, we started with we started with the first term and we went all the way down to adding the 7th term. So we added up all of these numbers, and when we do, we get that the answer to this is 56, the sum of all of these numbers. And finally, the index of summation is going to be this variable right here, the reference variable in a sense, that we're using to let you know which index numbers, which numbers, t values from 1 to 7 that we're using. Example 1, find the sum of an arithmetic series. Find the sum of the first 100 positive integers. I would be remiss if I didn't tell you or share with you the story of Carl Friedrich Gauss. Literally all over YouTube, you can find little stories about his history and one particularly noteworthy experience of his that is fabled to be his when he was in elementary school. So you've got this teacher who is at the board asking the kids to add up a bunch of numbers. And then finally he gets to a point where he's like not wanting to engage with them. And so he continues going on and on, watching the hands fall and the interest in a sense wane in his in answering his question. And he gets up to 100 and he sits down, and there's only one kid in the room, our guy, and he is calculating this number. What is 1 plus 2 plus 3 plus 4 plus 5 all the way up to 100? And he answers it. And later we will find that he answers it much to the teacher's chagrin. Because the teacher's like, how did you do this? What's the answer? And at the end of this particular rendition, there's a spanking, which is pretty sad. But the story goes that the kid figures out that the answer is 5,050. And we're going to skip the sad parts, and we'll talk a little bit more about how this will apply to our work today. So what he basically did was recognized a relationship between the numbers that he was adding up. So for instance, let me get a black pen. If you think about adding up the numbers 1, 2, 3, blah, 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 98, 99, 100, 100, you realize you're adding, if you add from beginning to end, you're adding a whole bunch of 101s, particularly you're adding 50 of them, and therefore 50 times 101 is 50/50. And I'm making light of this, like this was super easy, pretty brilliant for a kid to come up with that. After this, I've seen one person say that his elementary school teacher was actually rather supportive and helped him to get into senior secondary school. But what is the formula? How do we memorize this? And how do we use this all the time? So basically, here's the formula that we're dealing with. We're dealing with the sum, the first two. So basically, S sub n is the sum of the values in a sequence. So if you wanted to find all of the values up to S sub n, right? So if n were 7, we're finding the sum of a sub 1 all the way up to a sub 7. You get me? So if we wanted to find S sub n, we take the number of terms divided by 2, and we multiply it by this, which looks sneakingly, suspiciously like how we found the nth term of an arithmetic sequence. That's not a mistake. Basically, we're taking the first term and the last term of a particular part of the sequence that we want to add up. We're adding the first and last term, we're multiplying it by the number of terms, and we're dividing it by 2. Very similar to what Gauss came up with. And here, what's happening is that if you did not have a sub n, if you do not know the last term, you only know the first term and you know how far you want to go, you can use this one. So again, how would we handle this? I want to know S sub 100 in this case. So I take 100 over 2 times 1 plus the final term 100. And you can see that we get 50 times 101, which would be 5,050. All right, let's keep going. So here in example 2, we're dealing with a radio station that considered giving away $4,000 every day in the month of August for a total of $124,000. Instead, they decided to increase the amount given away each day or every day while still giving away the same total amount. So they're going to continue giving away a total of 124,000, but now they want to kind of up the ante every day. So each day they'd increase the amount that they were going to give away by $100. If they want to increase this amount by $100 each day, how much would they give away on the first day? So this is an arithmetic sequence where basically a sub 1 is the value that we're looking for. How much do we give away on the first day? Hopefully you realize that D is 100. That's our change amount, or our common difference of each of the terms. Since there's 31 days in August, n will be 31. And so we're going to use, so we know we're going to use a summation because they've given us the total amount of money that we're going to give away over this particular season. So what I'm going to do is I'm going to come back with that equation we had in the last problem. And we're going to use this equation to substitute in the values to see if we can solve for a sub 1. So $124,000 goes here, and in all the n values, we're going to put 31, and we don't know what a sub 1 is, so we'll leave that blank for now. We've got 31 minus 1 here, and 100 here. So with a little bit of algebraic manipulation, we can definitely solve this. Dividing both sides by 31 at this point. Here I multiply through by the 1/2. Dividing both sides by 31 yields me 4,000 over here, and the 31 is gone over here, and you can see where this is going. We're going to subtract 1,500 from both sides, and it's going to leave me with 2,500 is that first term. So $2,500 or $2,500 is how much they began giving away. Let's keep it moving. So we're looking at this next one. Find the first 3 terms. Find the first 3 terms of an arithmetic series in which a sub 1 is 9, a sub n is 105, and the total sum is 741. Let's set up our equation. So first, let's use the simpler of the 2 summation equations to the 2 series equations in order to figure out what the n value is. So if S sub n is equal to 741, let's put that there. Not sure what n is, but we'll find out soon. And we know the first and last term of this series would be this. So now we're going to add those together. Over here we're getting 114 times n over 2 is equal to 741. Keep working, and we end up with n is equal to 13. Now we're going to take the other equation from the last section where we relate the first term and the last term and the common difference, and we're going to use that in order to get the common difference. So that'll help us get through and find all the first three terms. So a little bit of math again, and we get that the common difference d is equal to 8. So now we know our starting point, which is important, and now we can find the first three terms. So 9, 17, and 25. So the final example is to evaluate this situation. So in this case, we're going to start with, we're going to deal with this. We'll look at it in two ways. Let's get rid of this. We're going to look at it in two ways. First, let's look at it the way we talked about the example earlier. So we're going to place the index numbers 5 all the way up to 8, 6, 7, and 8. And then we can calculate each of these terms. So you can totally see this is an arithmetic sequence, series, and so we're adding these values up. And when we do that, we get that the final answer is 62. But as promised, we could look at this a different way. If you can recognize that this is an arithmetic sequence in the beginning, you can simply find a sub 1 and a sub n, or the first and last term. In this case, the first term is 11 and the last term is 20. So if we can do that, then we can use the summation notation, right? S sub 4 has to be equal to 4 over 2 times the first and last term. Are you guys kind of with me? So where is this coming from? S sub n is equal to n over 2 times a sub 1 plus a sub n. So if we continue with this, 20 plus 11 is going to give us 31. So we've got 31 times 4 divided by 2, and you guessed it, that's going to be 62. All right, let me know if there's any questions or concerns. Of course, I look forward to talking to you guys soon. I know new notation like this is weird, so give yourself a moment, some break, some time, look at some videos online if you'd like to in the meantime, and let's talk about it again. Take it easy, guys. Bye-bye.